Hello students, so now we are going to start with our next chapter, that is kinematics. Okay, and from here actually our real chapter starts with kinematics, from where in JEE main and JEE advanced questions are asked. Okay, and this is very important and very basic chapters. Okay, so mainly you can understand the sequence which we are going to follow in the physics we are in this course is basically the next chapter we are going to study is will be using the concept which we study now. Okay, so basically next chapter which we're going to study will use this concepts a little bit of. Okay, and then build up on that there will be more concepts. Okay, so when in J advanced the questions are asked, they are asked in mixed format, like there will be something kinematics will be used. Okay, then little bit of something else chapter and other chapters will be used, like that. It will not ask from a particular concept, it will give just directly use the formula and you get the answer. No, it's not like that. Okay, JEE main they can give directly question from kinematics and it is asked. Okay, not that much frequent because this is very first chapter of the physics, right? And as we will go ahead, the weightage of the chapters will increase. Okay, so now let's start. So okay, now in kinematics we start with first definition defining our mechanics. So what is mechanics? So basically in mechanics what we study is motion of the body and causes behind the motion of the body. Okay, so when a body is moving and by what things it is moving. Okay, let's say it's a particle. Okay, in a particle in a box. Okay, in a room there is a particle. Okay, now particle is moving, study of that, what is the velocity, how it will go, what with other molecules it will collide, and then in which direction it will go. That is basically study of the motion of the particle. Then by what it is getting movement. Okay, that is basically temperature, what temperature it is in, and how much pressure it is there. Okay, and like that, density of the other in the room of the molecules, like that, this will be affect the motion of the particle, right? So that is basically study mechanics. We study motion of the body, any body, and causes behind the motion. Okay, now here two things are defined: static and dynamic. So static is basically you are analyzing the body when it is not moving, it is at rest. Okay, it is at rest. And dynamics means you are analyzing the body when it is moving. Okay, you are studying that body when it is moving. Okay, so this is basically two definitions. Okay, now further we divide dynamics in two parts. One is kinematics, one is kinetics. So kinematics is basically you study only motion of the body. You don't study about the causes behind it. You don't study about the temperature, pressure, or anything like that. Okay. And second thing is kinetics, where you study about the cause behind it. Okay. Here is cause of motion of a body is studied. Okay. And here motion is studied without knowing the cause of it. Okay, here basically cause of motion is studied without knowing the cause of it. Okay, and here cause of motion is of a body is studied. Okay, basically these are kinematics and kinetics. Okay, now next thing, further we divide kinematics in three parts. Okay, one is rectilinear motion, one is motion in a plane, and third is relative motion. Now first understand what is rectilinear motion. Okay, so in bracket it is written motion in 1D. So when your particle travels in a straight line, so in a straight line he can go ahead. Okay, and then he can come back also, but it will move, it should move in a straight line only. Okay, that is basically rectilinear motion. Okay, it can move, it can take turn, but in the same line only. Okay, it can't go on the other line. Okay, and this is rectilinear motion. Okay, motion in a plane is basically it can go in x and y direction both. Okay, in a plane. So in this paper, xy axis, it can go anywhere, it can go like this. Okay, this is basically your motion in a plane. Okay, then relative motion. So third, there in this chapter we divided in three parts. One is rectilinear, one is motion in a plane, and third is relative motion. Okay, so there basically we will study relative motion also. I will define there clearly what is relative motions, what are other in that, other things in that we will define completely. Don't worry about it. So kinematics we are dividing in three parts. One is rectilinear, One is motion in a plane and third is relative motion. So first we are starting with the rectilinear motion. So as I said, motion in a straight line. Okay, it can increase the speed, it can decrease the speed, it can stop, but everything he will do is in a straight line only. Okay, that is basically. Now next term which we are defining is rest and motion. Okay, rest and motion. So what we understand by the rest and what we understand by the motion. Okay, so you say something is stopped, that is rest. Okay, something is moving, that is motion. Okay, this is not exactly the thing. Okay, you understand the thing. Like let's say we take an example of bus. Okay, in a bus, say this is your bus. Okay, and here a man is standing and bus is moving with v velocity. Okay, now if you are here and I am here, okay, so according to you I am at rest, we both are sitting in a bus. Okay, so according to you I am in the bus only, right? So according to you I am not moving, right? But if the someone else will see from outside, he will see that I am moving, right? So how you define rest and motion? So what is written here? If a body does not change its position with respect to time as seen by the observer, then the body is in rest. So what is written here? By the observer. So here in the first case, observer was you. Okay, so in that case, according to you, my distance from you is constant, right? It is not changing. So that means according to you I am not moving. But if we change the observer, observer now is in the on the ground, right? So according to him, this distance is changing because this have a speed, so this distance is changing. So as the time passes, this distance will change and he will see that distance is changing means he is moving. Okay, whether the distance decreases or increases, okay, it doesn't matter. Okay, now second thing is, if it changes with its position with respect to time, then it is said to be in motion. So if it is not changing, it is rest. If it is changing, it is said to be in motion, but with respect to that particular observer. Okay, understand this thing. Okay, so rest and motion is defined with respect to observer who is seeing the object. Okay, that depends. Next thing, there is no such thing as absolute rest or absolute motion. Rest and motion is always defined with respect to observer. Okay, so what do you mean by absolute rest and absolute motion? Okay, see one thing, if you say on earth, okay, you are sitting here. Okay, so what you will see that you are at rest, right? But let's say if someone is on Mars, okay, what he will see, if you are sitting, you will see that some other person will see that you are at rest, right? Okay, with respect to both are sitting on the earth. Okay, both are sitting in room. Okay, so this is at rest. But when you will see from outside earth, so earth is spinning, right? So earth will spin, so you will rotate, right? So that according to him you are rotating, right? So it is not like absolute rest or absolute motion, means you can't say it is at rest. Okay, it is according to you, but when someone else will see, it is moving maybe, or maybe it is at rest. So you can't define exactly it is at rest or exactly it is at motion. Every single particle in the universe is relatively moving or relatively at rest with respect to each another. Okay, it depends from where you are seeing the object. Okay, so that is basically, there is nothing like absolute rest and absolute motion. Okay, next terminology we are going to define is distance. Okay, we are going to define each and every quantity. Distance, length of actual path traveled by the body is called distance. So what we are saying is distance about is, so let's say this point is A. Okay, you are starting from A, you are going like this and you are reaching the point B. Okay, and you are going like this. Okay, so the length of this path, let's mark in general point here C. So length of path, length of ACB, okay, ACB is your distance traveled, distance traveled. Okay, this is ACB, sorry, ACB is your distance traveled. Understood? So this is basically called as distance. Now we are defining that distance is a vector quantity or a scalar quantity. So distance is basically a scalar quantity. Okay, scalar quantity is vector quantities we already defined. Unit of that is in meter, SI unit, right? And dimension is m0, L1 T0, right? Okay, these things we have already studied. So according to that I'm writing. Next terminology we are defining is displacement. Okay, displacement, it is the shortest distance between initial and final position. Okay, so basically same, let's take the same path A. Okay, you are going like this and you are reaching the point B through this path you took. Okay, so now shortest path means this. Okay, this is basically your shortest path. Okay, so what we are saying is, let's take one more path like this, you can go, right? So this is your first path, this is your second path, this is your third path. Okay, and you're going from A to B. So the shortest path is what? This second path, right? So your second path is basically your displacement. Okay, and displacement you are defining directly going from A to B. So B is the end of it and A is the starting of it. Okay, and this will be always a straight line. Okay, so we define that displacement is a vector quantity. Okay, the end of the vector is the end of your where it is ending its motion. Okay, where it is stopping or where you are taking the end point, that is your end of the vector, head of the vector. Okay, and from where you are taking as a starting point, that is your tail of the vector. Okay, so it's a vector quantity, unit same, m0, sorry, unit will be in meter and dimension will be m0 l1 t0. Okay, this will be your dimension. So here I can say distance in third part is bigger. Okay, and then distance in first part, and then distance in second part, right? So this is the sequence, right? So displacement is the always shortest path. So I can say displacement is basically the second path. Okay, that's all, that's the answer. Okay, path 2 is the displacement vector, displacement, right? The whatever length it is, AB, directly straight line. And distance in all, displacement in all these three cases, displacement in all three cases is same. So what we understand by that, that displacement doesn't depend upon the path taken. Okay, whatever path you take, it is coming same AB only, right? Okay, so basically displacement doesn't depend upon the path taken, it depend upon the initial and final position. You define initial final position, then calculate direct straight line between them. Okay, that is basically your displacement vector. Okay, directly. So in general we can say distance is greater than or equal to displacement. How? Basically displacement magnitude. Why? Because displacement is a vector quantity, so we can take magnitude here to equate it. Okay, we can't equate vector quantity with scalar quantities, so that's why. Okay, so what is defining distance is greater than or equal to displacement. So greater than, you understand, if you took another path, that is basically distance will be bigger, right? And displacement is the shortest path. But if you took this AB path only, AB path you took, okay, straight line only, then your distance and displacement will be same. Okay, so in that case they will be equal, otherwise distance will be greater than displacement. Okay, displacement of a body is independent of path taken by the body, it only depends upon initial and final position of the body. So I defined this already. Okay, I told you how to do that. So what it's saying is that initial and final position, if you mark, I will directly can draw a straight line and I can directly calculate the displacement, right? It doesn't matter which path you are taking. Okay, in first path, second path and third path, all displacement is same, AB only, so it doesn't matter, doesn't depend upon the path taken. Now for calculation of displacement, draw a vector whose tail is at initial position and head is at final position. This also I have told you. So vector will be pointing this side, this will be its head, right? Next thing, distance traveled by a body can never be negative, whereas displacement of a body can be positive, negative and zero as well. So distance is always increasing. As you moved the particle, it increasing, right? But because displacement is a vector quantity, so vector can be negative also, positive also and zero also, right? Okay, so that is basically displacement is positive, negative or zero because it's a vector quantity. Distance traveled by a body never decreases with time. So what he's saying is distance traveled by a body never decreases with time, because it's a always positive quantity. As soon as you moved it, it became some value, right? Some positive value. Now it can't go decrease, it can't decrease. Okay. When you will go back to that position, it will be calculating both things. Okay. Understood? It is getting add up only. If you stop, that time it will get 0. You don't not moving, it will not increase, but you can't decrease it. Okay. So let's see one question we have. Okay. So what this question is saying is that you have to comment on the it is possible or not. Okay. That we have to define. So distance versus, so you have to see distance versus time graph. Okay. So with time, distance is increasing. Okay. So that is possible, right? I can say it is possible. Then this is first with time distance increase. Okay. Then time decrease. Here he is defining decrement time. So there is not possible. Okay. Not possible. Because why? Because time is decreasing. So that case, so here time travel is negative. That is not possible. Okay. So this is not possible. Here what is happening? Distance increase with time and then distance decrease. So distance can't decrease, right? Okay. So not possible. Why? Because distance can't decrease. So you have to see that it's a displacement. If it was a displacement versus time graph, it is possible. But because it is a distance versus time graph, it is not possible because distance can't decrease. Okay. So this is basically not possible. Why? Because distance can't decrease. Okay. Decrement. And then here both things are happening. Here if you take this path, okay, you're going like this and coming back. So this is basically what you're doing. First distance is increasing with time and then you are decreasing the time and decreasing the distance. So both things are happening together. This is not possible. Okay. Let's do next question. What we have in next question is calculate distance traveled and magnitude of displacement. Okay. So what we have to calculate distance and displacement. So this is your initial point A, this is point B, and this is point C. So some particle traveled this side 4 and this side 3. So what is distance? Distance is path traveled. So 4 plus 3. So 4 plus 3 is 7. Okay. And displacement is distance displacement. Displacement is how much? Direct shortest path. Shortest path is this. So this is hypotenuse of this triangle. So that will be under root of 4 square plus 3 square. That is 5 meter. 5 meter I can say this is 7 meter. Okay. With units you have to answer. Next question is we have is this is a straight path A and this is B and this is C. So this is a semicircle of radius 1 and this is 3 meter. So what can I say about distance? Distance, how much is the distance? Distance is 3 meter, okay, plus this length. So this is length is how much? Pi r, okay, semicircle. So 2 pi r by 2, so pi r. So 3 plus pi into 1, so 3 plus pi meter. Okay, then we have displacement. Displacement is how much? From A to C directly. So this is 3, then this is 1, this is 1. So 3 plus diameter. So this is 3 plus 2, 3 plus 1 plus 1, that is 5 meter. Okay, I hope it is clear. In next video we are going to solve more questions on this. Okay, and then we are going to see next thing. Next question we have is a car travels 10 meter towards east, okay, and then 20 meter towards north and finally 40 meter towards west. Okay, calculate distance and displacement. So what he is saying is a car travel towards east. So in general we make the direction like this. Okay, so car travels 10 meter towards east. So first he is saying 10 meter towards east. Okay, 10 meter towards east. So towards east he went, and then after 20 minutes to 20 meter towards north. So 20 meter towards north like this, 20 meter, and then 40 meter towards west. So then towards west 40 meter, this much, like 40 meter. Okay, this calculate distance and displacement. So directly distance we can say directly 10 plus 20 plus 40, that is how much? Okay, 70 meter. For displacement means distance between this point and this point, right? This we have to answer. Now how to calculate this? You draw a perpendicular here, okay, and draw a line here, okay, and that's all. So this is 10, so this is how much? 30, and this is how much? 20, right? So this will be your displacement will be under root of 20 square plus 30 square. Okay, this will be your displacement, that will be under root of 1300 meter. Okay, this is your displacement. This is how you calculate, or you can solve in vector form also. This is 10 I cap, right? Okay, so if we solve in vector form, okay, let's solve in vector form. So displacement is a vector quantity, right? So we can say, let's mark this point as A, this point as B, this point as C, this point as D. Okay, so we have to calculate what? AD vector. D is the final point, right? And A is the initial point. This vector is sum of this. So this is 10 I cap. If you take x, y, sorry, this is x, this is y. Okay, so in x direction how much? 10 I cap. Then you moved this side 20 j cap, right? 20 j cap. Then you moved 40 this direction, means minus 40 I cap. Sum of this all is displacement only. AD vector. What is AD vector now? It came. So this is minus 30 I cap plus 20 j cap is the displacement. Okay, this is your displacement vector. Okay, so magnitude of displacement is how much? Again same thing, right? Under root of 1300 meter. So this is how you can find out the displacement magnitude and direction both. Okay, directly you can do like this. Okay, otherwise you can find out the displacement by simply using the trigonometry. Next thing, a man travels 20 meter towards east, then 40 meter towards 37 degrees south of west. Okay, this you have to understand how it is going. So xy direction. So as he talked about east west, I will draw this thing: east, west, north and south. Okay, this thing, as soon as he told east west, he discussed, I will draw this. Okay, then he traveled 20 meter towards east, so 20 meter this direction, 20 meter. Okay, then he said 37 degrees south, so you have to turn 37 degrees south from west, of west. So from west 37 degree you have to turn towards the south. Okay, so this direction he moved. How much? 40 meter. Okay, so this is how it moved. Okay, now let's draw in x I cap j cap form. Taking this as origin, we can take anything, any position you can take origin. So this is A, this is your B, and this is your C. Okay, so if you calculate distance, if you ask distance is what? Path traveled. So path traveled is 20 plus 40, that is 60 meter. Okay, and your displacement. So displacement is basically AC vector, right? So AC vector, I can say AB vector plus BC vector, right? So AB vector is how much? AB is 20 I cap, 20 I cap, plus BC vector, I can say this is 40 cos theta I cap, that is negative I cap, right? So minus 40 cos 37 I cap, and J cap also it is negative, right? So minus 40 sin 37 J cap. Okay, you can see in the vector which we discussed. Okay, there we defined exactly how to divide any vector in component form. Okay, so this is what AC vector. So AC vector, if you calculate, finally it will come minus 12 I cap minus 24 J cap. Okay, so magnitude is how much? Magnitude is under root of 144 plus 256. Okay, you can answer this. Okay, I hope you will able to answer. Okay, so how much it is? 300, 400, under root of 400. Okay. Okay, so this is in meter, 20 meter I guess, yes, 20 meter. Okay, now do the next question. Okay. Next question is also similar, you will understand this thing better. What is given here? East, west, north and south. Okay, this is direction. This is little bit of complicated thing, so we will draw all the diagrams separately, all the vectors we will draw separately. First, man travels 20 meter. Okay, so 20 meter, where it travel 53 degree north of east. So 53 degree north, 53 degree north you have to turn from east, of the east, of east. So 53 degree towards this side, 20 meter distance, how much angle? 53. Okay, this is your first vector. Okay. Then you have the second thing, what? Then 10 meter towards south, then 10 meter towards south. So second vector is 10 meter towards south, 10 meter. So actually you can replace the vector here from here. Okay, here it is like this, but I am drawing here. Why? Because I don't want to make it too much of complicated. Then 37 degree north of west. So 37 degree north, 20 meter, 37 degree north of west. So from west side you take 37 degree north. Okay, so 37 degree north side, so 37 degree. Okay, how much this distance? 20 meter. Okay, these are your three vectors. Okay, so if you write distance, distance is basically sum, so that is 20 plus 10 plus 20, that is my 50 meter. Okay, and if you write displacement, final displacement will be how much? This is vector you can divide in component form. How you will divide? 20, this will be I cap, positive only, so 20 cos 53 I cap, okay, plus 20 sin 53 j cap, plus which vector? This one, this is minus j cap, so minus 10 j cap plus this one vector, this is negative I cap, right? So minus 20 cos 37 I cap, okay, and j cap direction what it will be? Plus 20 sin 37 j cap. Okay, this is your vectors. Now you resolve this. Okay, this is just a calculation part, you can do that. So this is gonna come minus 4 I cap plus 18 j cap. This is your final answer. Okay, so this is in displacement, you can calculate the magnitude also. Okay, next question we have is a particle started from 1, 2, 3 and goes to 3, 4, 4, 5 via point 0, 1, 2. Okay, so these are x, y and z coordinates are given. Okay, find distance and displacement of the particle. So he started from 1, 2, 3, A, let's say, and he went to some point B which is at 3, 4, 5, and he went in here like 0, 1, 2, he went first here. Okay, so all between two points it's moving in a straight line. So this is kind of, he moved like this and then he moved like this, straight line. Okay, like that he moved. So this is, let's say, C point. Okay, so first he went AC, then CB, like that he went. So I can say distance is equals to what? Distance is magnitude of AC vector plus magnitude of CB vector, right? This is your distance. So that you can calculate distance. Okay, distance formula you know. Okay, distance formula is basically 1 plus 1 plus 1, okay, under root of, and this is your 3 under root of 3 square, so 9, and then it is also 3 plus 9 plus 9. Okay, okay, this is your 4 root 3 will come. Okay, 4 root 3 meter, like this, and then this. Okay, displacement is also easy. Displacement is what? AC vector plus CB vector. Okay, That is, I can say this sum vector is equal to your AB vector. Displacement is what? This vector. Okay, AB vector. So AB vector is what? B 3 minus 1, that is 2 I cap. Okay, 4 minus 2, that is 2 J cap, and 5 minus 3, 2K cap. This is your displacement. Okay, I hope this is clear. Okay, thank you.